If you want your software development team to deliver code better, faster, and cheaper, this video could help. We're going to spend a few minutes talking about dirty comments and clean comments, and how dirty comments can lead to catastrophic results when deploying software to production. This is a very unusual format. It's part of the blockbuster training that my brother and I have been working on for more than a decade. So when we do these sessions with teams, it's always a lot of fun. It's a different way to become better software developers. It's much more interesting and engaging than traditional training. So let's go over this specific episode, and it's a little tiny fragment from the whole blockbuster training. And in this specific part of the story, the animals are trying to restore access to satellites so they can continue searching for humans. The human race vanished. And the animals are trying to, they're scratching their heads and trying to figure out where the humans went and what happened. So let's just go into this part of the training. Rocky the raccoon says, as we recover satellites, we will be attacked. We know that. There is an enemy, there are aliens or something out there. And it happened in the past. They keep destroying us. So as we restore our satellites, we need to build we need to defend the perimeter, he says, and we need kamikaze satellites. So when we are getting attacked, we have like this layer of protection. When the enemy approaches, the kamikaze satellite destroys itself with the enemy. And this way we are protecting the rest of our fleet, he says. Meet Cyclomat. Cyclomat is a ginger cat. He is not a clean coder, and he makes lots of mistakes, and he improves, but his code is a bit dirty, and he's very keen to deliver code, go ahead, and very enthusiastic cat, but unfortunately not a clean coder. So let's see what he does. He delivers a class called Perimeter Defender, the defend method. They scan for threats. If at least one threat found, they select the top priority threat and then destroy it via kamikaze attack. Now, if you look at this method here, they log the attack, they notify the mission control center, and then they set this flag here, self-destroy off, to false, meaning that it's gonna explode. So let's have a look at the satellite class where this flag resides. So that's the flag, self-destroy off. So what Cyclomat does as he delivers this class, he adds a comment. And it says, when set to false, self-destroys immediately. And it makes sense. The comment makes sense at this point in time. And we're going to talk about how this comment backfires and leads to catastrophic results just in a few seconds. Then there is a method here within the satellite class called self-destroy if triggered. And there is a check. If this flag is not false, then it engages the self-destroy mechanism. And then let's not go into the details of this method. And that's a simple code and pretty clean. It's not the cleanest code, but not bad. Not bad. Well done, Cyclomat. 2 weeks later, Cyclomat's colleague, Taylor, comes in and says, I hate double negations. Look at this. We have self-destroy off, which is kind of a negation, and we set it to false. So we use double negation to engage the self-destroy mechanism. He doesn't like it, and that's really a good thing to do. He's inversing it. He's renaming the flag to just self-destroy flag and sets it to true. He also obviously renames it in the satellite class, and he inverses this condition here. So eliminates double negation here. So the code becomes a bit easier to read. There is no need to parse double negations as you read and maintain the code. He likes it. But in 2 weeks' time, Champa comes in and she looks at this comment here, which says, when set to false, self-destroys immediately. She examines the code and said, hang on, when we call destroy, it's set to true, but the comment says false. So she goes off and updates the code accordingly. And she fixed the bug in her mind, and she's happy. But let's see how it all unfolds when they deploy this version of their perimeter defense software. Boom, boom, boom. They lose their satellites. So it didn't work. And they're troubleshooting the problem. They're trying to figure out what went wrong. Trinity, a clean coder, helps them to investigate. And she explains that when they scan for threats and at least one threat found, they select the top priority threat, destroy by kamikaze attack, log it, notify, and then they set self-destroy flag to false. And when they go inside of this method here, this flag is set to false, so it doesn't engage the self-destroy mechanism. So she goes, it must be set to true. And Champa says it was set to true before, but she changed it to false. When asked why would she do that, she validly points at this comment here. When set to false, self-destroys immediately. So what happened here is obvious. As they work together as a team, that comment here backfired on them because as they were refactoring the code, they forgot to update the comment. And this is a typical pattern. When we use, this is one of the patterns with dirty comments that become stale over time, and when developers don't update them, and they pay attention to the comment, that can lead to catastrophic results, like we demonstrated in this episode. And that's about it. How to fix it? Just remove redundant comments. Just use clean code instead. This code here could be improved dramatically, but that's a topic for a completely different session. I hope it was useful. If you enjoyed this format, this way of upskilling your team, give this video a like or share it with your network. And I'd be happy to brainstorm if you're passionate about it. And maybe I can share a few slides like that with your team if you're interested. So get in touch if you want to. Thanks for watching.